Humans have always been transient visitors to the moon. Land, plant a flag, come home. But as of 2026, that era is over. We're finally activating the Lunar Gateway, a permanent orbital laboratory parked in deep space, built to solve two problems that have kept us chained to Earth for 50 years: lethal radiation and life support with nobody around to fix it. This isn't a flag-planting mission. It's a proving ground. And if its autonomous systems fail out here, our dreams of ever reaching Mars are effectively dead. Apollo astronauts spent a few days near the moon, then came straight home. Gateway's Halo module never leaves. It lives in something called a near-rectilinear halo orbit, a strange, elongated path that swings from just a few thousand kilometers off the lunar surface out to tens of thousands more, looping around roughly once a week. It sounds unstable, but it's actually a gravitational sweet spot, balanced between the pull of Earth and Moon, so a station can sit there for years while burning almost no fuel to stay put. That stability is exactly why it's the staging ground for the next decade of exploration, including the radical propulsion technology that keeps the whole station there without a single massive fuel tank.
That propulsion technology is the power and propulsion element, and it doesn't fly like a normal rocket. Instead of burning chemical fuel in one violent burst, it uses solar panels to ionize xenon gas and fires it out as a thin, glowing stream of thrust. The result is roughly 10 times more efficient than a chemical engine, trading raw power for months of steady, patient thrust. Every day it operates, engineers gather real, long-duration data on how these thrusters hold up over time, reliability data that will eventually decide whether we trust this exact engine to push a crew and their supplies all the way to the red planet.
An efficient engine means nothing if deep space kills the crew before they arrive. So Gateway is wrapped in sensors, inside the hull and outside it, constantly mapping exactly how heavy cosmic ions punch through a habitat's walls. That data is already driving new shielding materials and early warning protocols that can flag a dangerous solar storm before it ever reaches the crew. These aren't theoretical safety measures dreamed up in a lab. They're breakthroughs you can only earn by actually living in the radiation month after month, not just simulating it on a screen back on Earth.
None of this matters if the station falls apart the moment the crew leaves. And for most of the year, nobody's home. So Gateway runs AI-driven environmental systems that keep air and water cycling on their own for months without a single human on board. Onboard robotic assistants run diagnostics around the clock, catching hardware failures and carrying out repairs without waiting for instructions from mission control. It's essentially a dress rehearsal for a 2-year Mars mission, where the crew can't just call home for help. A radio message alone takes up to 20 minutes each way, so the systems keeping you alive have to think for themselves.
2026 marks the point of no return for deep space mission architecture. Every failure Gateway surfaces here 3 days from Earth is a catastrophe it quietly prevents on the first crewed transit to Mars, months from home, with no way back. It's why nearly every major spacefaring nation is building toward this same outpost together instead of racing separately. Gateway isn't just a lunar station orbiting an empty rock. It's the first true shipyard of the deep space age, the place where humanity stops visiting and starts building the road to Mars.
That's how the 2026 Lunar Gateway is quietly rewriting the rules of deep space travel, one autonomous system at a time. If you want to watch humanity's actual road to Mars unfold in real time, subscribe, and I'll see you at the next mile marker.